Good afternoon, Robert Scribbler. It is December 7th, 2018. Thank you for joining me for another climate change and clean energy video blog. Now, for this segment, I am going to talk about something that is a pretty big deal. And it's such a big deal now that many mainstream publications like the Washington Post here consider it to be front page news, and that is that global carbon emissions have reached a new record level. Now, what that means is that the annual global carbon dioxide emissions from primarily fossil fuel burning has increased this year and hit a new record level. And that's something that affects us all because the velocity, it impacts not only the damage that we are seeing from human-caused climate change at present, but the velocity at which we will see increasing harms in the future. If you continue to emit carbon emissions on a mass scale, you end up seeing more and more damage to the Earth system, to the climate system, and to human communities around the world. And the more you emit each year on a mass scale, the more rapidly we see those impacts occurring in our communities, in regions where we live, and around the world. So before I get into the nature of this report, I would just like to note that when you continue burning fossil fuels, there are a number of things that happen. And in very brief, what happens is the weather extremes worsen, so we tend to see more impacts like the Camp Fire in California, of which we're looking at a satellite shot from NASA here at present. We tend to see more extreme wildfires, more extreme droughts, more extreme water shortages in some regions, and we tend to see more extreme rainfall events and more extreme storms as well. And the reason for this is that as the Earth warms, it amplifies the intensity of the hydrological cycle, so evaporation rates increase, and to a certain point, precipitation rates increase. In addition, we tend to see less productive oceans. More of the ocean life is shut off as oceans become less oxygen carrying, and more toxic microbes tend to fill the ocean. So we tend to see more harmful algae blooms like what we saw in Florida. And as the Earth warms, the oceans become less and less of a safe haven for life, for complex life as we know it, and more of a haven for a kind of toxic ocean state. What also happens is that glaciers melt at around 5 or 6 degrees Celsius warming globally. You end up melting most or almost all of the major ice masses in the world over time. As a result, seas rise, and if you have warming in the range of 5 to 6 degrees Celsius over time, the amount of sea level rise that you get eventually is in the range of 200 feet, which is enough to wipe out most coastal cities and most coastal communities. Now, the pace at which these things happen are governed by two things. One, it's governed by the sensitivity of the Earth system, and two, it's governed by the rate at which we burn carbon. Now, the sensitivity of the Earth system itself is a matter of some debate among the sciences, but over recent years, the sensitivity of the Earth system has seemed to, at least in a number of parameters, being more sensitive than we would expect. And so as a result, we are tending to see more harmful impacts from climate change coming sooner than we expected. The second aspect, fossil fuel burning, has been continuing to rise, even though the rate of fossil fuel burning and the rate of global carbon emissions over the past 5 years has dropped a bit from historic rates of rise in, for example, the decade of the 2000s, which saw a very rapid ramp up in global human-based carbon emissions. So just a very basic picture of what happens if you continue to burn fossil fuels and if you speed up the burning of fossil fuels. And that being that we see the harmful impacts of human-caused climate change, the devastating impacts of human-caused climate change happening at a faster rate if you ramp up fossil fuel burning, and happening over time at a dangerous rate if you continue fossil fuel burning for an extended period into the future. So the center of gravity, the primary issue when it comes to human-caused climate change, is tamping down fossil fuel burning. And at present, the world is struggling to do that. And the reason why the world is struggling is for a number of reasons. First of which, the growth engine for the global economy is access to energy. And at present, the largest pool of energy currently in use is from fossil fuel burning, even though the use of renewables is increasing. And secondly, we have had the reintroduction of political influences in places like the United States, in Europe, in Australia, in Brazil, that tend to favor fossil fuel burning over a more rapid transition to renewable energy. And I'm going to get into a little bit more of the details as I go over this report from the Global Carbon Project, which has set off these headlines. Many of them are looking rather grim. And what I will say is that for myself, the state of the situation remains basically the same. And it's something that I talked about in my book Growth Shock, which published a few years ago, so it's dated. It published back in 2013. But what I was basically talking about is what a number of other sustainability experts have pointed out, and I just really wanted to highlight, is that if we link economic growth on a global basis to fossil fuel burning, we are paving a course to our increasing destruction and dismantlement of our civilization by spurring terrible natural forces, in a sense, weaponizing the climate system against us, against human civilization, in such a way that over time the harms ramp up to a point where it is highly unlikely that human civilization will be able to adapt. You have to get off the fossil fuel burning bandwagon and bandwagon into a kind of like a hellish earth state in order to have hope of dealing with the climate crisis. Now, unfortunately, since we have already burned so much carbon dioxide, so much in the way of fossil fuels, and increased atmospheric carbon dioxide to above 400 parts per million, now in the range of about 410 parts per million, and in the range of about 492 parts per million CO2 equivalent, when you add in all the other greenhouse gases emitted by human activity, we are already looking at harms from human-caused climate change. So what we are trying to do right now is prevent catastrophe. And in the most simple respect, we can prevent that catastrophe by rapidly transitioning to non-carbon-based energy sources, which means transitioning away from oil, gas, and coal. And we need to do this on a global basis. There's not any one nation that can do it all by itself. We've all got to work together, and we've all got to take responsibility both as nations and as individuals. So just an overview of the situation at hand, the risks that we face, the impacts that we face, and the choices that we need to make. In the parlance of the military, the enemy is before us, and we're getting the incoming fire coming from the enemy right now, and unfortunately, unless we respond in a very dramatic, very direct fashion, that incoming fire is just going to keep getting worse and worse. So unfortunately, we have a fight before us, and the fight, in many respects, is for the life of human civilization and for many of the vital Earth systems that we rely on as human beings for our health, our wealth, and our prosperity. So looking at I'm going to look at some graphs that have been provided by physics.org because this particular article by a number of writers over at physics.org has boiled down a rather large body of research in the form of 3 studies from the Global Carbon Project. And I'm going to talk about the present state of play and provide you guys with some analysis. So what happened in 2018 is it looks like global carbon emissions overall increased by about 2.7% to around 37.1 billion tons of carbon dioxide emitted from primarily fossil fuel burning every year now. And that rate of burning is extraordinarily rapid, extraordinarily rapid carbon pulse into the Earth system. It's about at least 10 times faster than during past worst hothouse extinction events. So what does that mean? It means that the human system is providing what they call a carbon flux or a carbon emission into the atmospheric system at a rate much, much faster than has ever occurred based on any like proxy data that we can accurately assimilate. And this extraordinarily rapid carbon emission is what's causing the present global heating crisis, global warming crisis, the present climate change crisis, and that is setting off the extreme events that we are seeing now on human timescales rather than geological timescales. So looking at the sources of the particular increases and total emissions of carbon that we are seeing, we have seen long-term growth in the rate of oil emissions in the form of carbon dioxide. We've seen long-term growth in the rate of gas emissions, and we've seen a relatively steady growth in the rate of cement emissions. But the primary contributor, coal, has dropped off in recent years, even though coal this year saw a bit of a bounce back by about 1% during the past year. So what's occurring is this fossil fuel burning across all sectors, oil, gas, and coal, is driving the massive global carbon emission that we see. And it's just worth noting, I'd like to point out that the most rapid growing contributor to the global warming crisis in the form of greenhouse gas emissions at this point is gas, which many in the fossil fuel industry said, well, gas should operate as a bridge fuel to a lower carbon economy. In all honesty, gas is not doing that. Gas is operating as a bridge fuel to extend global carbon emissions at a time, or extend global carbon emissions increases at a time when we should be rapidly ramping down global carbon emissions. Now, it is worth noting that at present we do have a number of clean energy sources that can replace these emitting sources, and I'm going to get into that a little bit more in the future. So, looking at geospatially where the emissions growth is coming from, it is worth noting that the largest emitters or largest contributors to increasing emissions are China, India, and the rest of the world. The U.S. did see a bit of a bump, a bit of a retrenchment in carbon emissions in the recent year, showing about 2.5% growth. But overall, the U.S. trend is for declining carbon emissions, as is for the EU, which has shown systemic declines in carbon emissions actually since the late 1970s. The U.S. has seen systemic declines in carbon emissions since around 2009, or the entrance of the Obama administration. At present, the Trump administration is doing everything it can to bring us back to a period in which U.S. carbon emissions grow, but it appears that the economics of renewable energy might win out in the end as long as federal policy does not become too hostile to renewable energy. It is worth noting that China's carbon emissions have the rate of carbon emissions increase has dropped during recent years, which is a positive sign. But what we are seeing is a relatively consistent growth coming from India, which is worrying, and a rather steep rate of growth coming from the rest of the world. So just a overall snapshot of what's going on with global carbon emissions. The overall rate of global carbon emissions increase during the past 5 years has tapered off, but we are still in a situation where we are seeing annual global increases in carbon emissions at a time when we need to rapidly reduce carbon emissions in order to avoid catastrophic impacts. And if we're going to have any chance of limiting warming to 1.5 degrees Celsius by the end of this century, we need to cut global carbon emissions by around 40 to 50% by 2030. And that's a hard line. 1.5 degrees Celsius warming does have some baked in bad impacts, but it's a lot better than 2 degrees Celsius warming or 3 degrees Celsius warming or even 4 degrees Celsius warming. And it's worth noting that present commitments to reduce greenhouse gas emissions have us on a pathway of around 4 degrees Celsius warming by the end of this century. That is a very rough path. It's not the worst case scenario path, but it is a very, very rough path. And we need to avoid that. We do not want to see a 4 degrees Celsius warming by the end of the 21st century, which would produce a great deal of harm and a great deal of negative impact. So looking at countries, we can see where certain countries have tapered off their rise in carbon emissions, where certain countries have shown systemic reductions in carbon emissions, where we've tended to see some growth or some plateauing in carbon emissions. Overall, though, the overall pace of growth at least has tended to slow down since the decade of the 2000s. Now, looking at energy consumption, and this is where the opportunity to reduce global carbon emissions exists. And I'd just like to point out that these three sources, nuclear, hydro, and all other renewables, added together result in about an avoided 4 gigatons of CO2 equivalent emitted every year. So because we already have a decent amount of non-carbon based energy sources installed, that does reduce our annual carbon emissions versus what we would see if all energy was based on fossil fuels. And this also shows us how we can get ourselves off of the massive carbon emissions that are currently being produced by fossil fuel burning. And that is primarily replace the large-scale fossil fuel burning from coal, oil, and gas with these renewable energy sources. Now, it's optimistic in one sense that renewable energy in the form of wind and solar is growing at the rate of 14% a year. And if that growth rate continues, competition with fossil fuels will help to start abate the pace of global carbon emissions coming from fossil fuel burning and eventually start to tamp it down. Now, how policy plays into this is if you have policies that incentivize a more rapid deployment of renewable energy, then the pace of reductions and avoided carbon emissions increases. And if you have a rather rapid deployment, then you can start to see some of those reductions that we need in order to avoid worst case climate change scenarios. So that is really the basic issue that we're looking at. Now, from the standpoint of certain regions of the world whose economies are wedded to fossil fuel burning, I think what we need to do is try to both be practical but also be aggressive and try and enmesh renewable energy into those regions as rapidly as possible. Places like Texas and West Virginia and the high carbon emitting parts of India and China, the Middle East. Those regions are basically the regions that are providing the impetus for slowing the response to human-caused climate change. And we need both a carrot and stick approach to those regions. We can't just say that if your job relies on fossil fuel burning, it's tough luck for you. We need to provide the replacement jobs and the replacement economies that are going to provide for those families that right now rely on fossil fuels for their bread and butter, and start insinuating the more beneficial renewable energy, clean energy economies into those systems, and providing pathways for people to escape from being wedded to the harmful cycle, the harmful economic cycle of fossil fuel burning. That is a very difficult thing, but it's something that we're going to need to confront. In addition, the regions that are leaders in clean energy are going to need to step it up. And we can do that through policy, but we can also do that as individuals. And increasingly, clean energy is becoming more accessible to us all. And part of the reason for that is that the cost of clean energy just keeps falling. Since 2013, for example, the cost of wind and solar in the low-cost segment is now competitive with coal and natural gas, and in many cases outcompeting coal and natural gas. And even the high-cost segments is becoming very competitive with both coal and natural gas from the energy generation standpoint. Now, in addition, electric vehicle battery costs are also falling very rapidly, which is providing more and more access to electric vehicles for us all. But if you or I want to help to accelerate this trend, we can do so with our dollars, we can do so with our votes, we can save money for clean energy systems like wind and solar, we can purchase electric vehicles and mate them with clean energy systems like wind and solar. Now, in addition, the lowering cost of batteries also provides an opportunity to replace both transportation fossil fuel burning and an increasing amount of electric generation fossil fuel burning. And this has been displayed by Tesla's giant battery plant, which is economically outcompeting fossil fuel peaker plants in Australia. So the mating of batteries with clean energy systems like wind and solar, and leveraging the mass economies of scale, the mass production, to provide a positive learning curve is a formula for more rapidly providing clean energy versus fossil fuel energy. But in order to do that as rapidly as we need to, we're also going to need the politics to come into play. We're going to need an Obama type or better administration in the US and federal leadership at that level of commitment or better, that provides an escalating series of climate policies that spur the more rapid deployment of clean energy, and in all honesty, disincentivize the use of fossil fuel burning. So that's the challenge we face at present, a challenge that we are struggling to achieve. And arguably, that though we have seen some success on a global level, where we have the opportunity to peak fossil fuel burning and global greenhouse gas emissions early in the time period of the late 2010s, that has not been realized. And in part, that's due to the failure of our politics, and in part, that's due to the fact that economic growth at this time, at present, is still mated largely to fossil fuels. And so anytime you see a spike in economic growth from regions that are heavy fossil fuel users, and when the aggregate size of the fossil fuel burning is larger than the clean energy burning, then you're going to tend to get a spike in global carbon emissions. And so we really need to look at this both from a policy perspective and from an economics perspective, in providing both what people need and the necessary transition to clean energy to prevent catastrophic impacts from climate change, which unfortunately are beginning to occur at increasing rates. So thank you for joining me, and I'll be chatting with you soon.